In this example, I'm given an equation 1 plus 2i squared, and that must equal to a plus bi multiplied by 2 minus I. And I need to find the values of a and b. So I'm going to separate my equation into the left-hand side and the right-hand side along the equal to sign. And 1 plus 2i forms the left-hand side, and the right-hand side will be a plus bi times 2 minus I. I am now going to simplify each side separately. So my left-hand side is 1 plus 2i squared, which can be written as 1 plus 2i times itself. So I'm going to multiply this out. So I get 1 times 1 gives me 1. 1 times 2i is 2i. 2i multiplied by 1 gives me 2i. And 2i times 2i gives me 4i squared. I know that I squared has a value of negative 1. So negative 1 multiplied by positive 4 gives me negative 4, and added to the 1 gives me negative 3. So I've simplified and added my real numbers. I do the same with my imaginary numbers, and I get 4i. I now go on and look at the right-hand side of this expression, and I'm going to simplify the right-hand side. So it's a plus bi multiplied by 2 minus I. So we multiply carefully. So a times 2 gives you 2a. A times negative I gives you negative ai. Bi times 2 gives you plus 2bi. And bi times negative I gives you minus bi squared. Once again, reminding myself that I squared is negative 1. Negative b times negative 1 gives me plus b. And the other terms cannot be simplified further because they're unlike terms and nothing can be added or subtracted. I'm going to move one step further where I'm going to group the real numbers together. So I'm going to write the two real numbers together. And then I'm going to write the two imaginary numbers together. But I'm going to take out I as the highest common factor, so I have minus a plus 2b. So I have two equations. The first equation is going to be me grouping the real numbers together, and the second equation will be me grouping the imaginary numbers together. So what I am going to do is I'm going to say negative 3. So the real number on the left-hand side can equal to 2a plus b, and this is equation 1. And then I'm going to do the same with the imaginary numbers, but I'm not. So I have 4i equals to minus a plus 2bi. But I'm going to rewrite my second equation without the symbol I. So my first equation again is minus 3 equals to 2a plus b. That's the first equation, equation 1. I rewrite my second equation as 4 equals to minus a plus 2b. And I'm going to solve these two equations simultaneously. So when solving equations simultaneously, we can either use a method called the elimination method, or we could use the substitution method. So I'm going to do both methods, but I'm going to start with the elimination method. And with the elimination method, if you know this method, you know that we need to eliminate one of the variables. So we can either eliminate the variable a or the variable b. So for me to eliminate one of the variables, if I have a look at equation 2 has a coefficient of a of minus 1, and in equation 1, the coefficient of a is positive 2. If I could make the coefficient of a in equation 2 equal to 2, then if I added equation 1 to equation 2, then I would get 0a, and that's how I eliminate a. So it sounds quite intricate, but let's start. So we're going to rewrite equation 1 So I have minus 3 equals to 2a plus b. Then I take equation 2 and I'm going to multiply each term of equation 2 by the number 2. So I'm going to double each number. So 4 times 2 in equation 2 gives me 8. Negative 1a times 2 gives me negative 2a. 2b times 2 gives me 4b. And now I am going to add these two equations. So I add negative 3 and 8, which gives me 5. 2a added to negative 2a gives you 0a. 1b added to 4b gives you 5b. So if we divide both sides by the number 5, we see that the value of b is 1. To find a, all I have to do is substitute this value of b into either equation 1 or equation 2. I'm going to substitute it into equation 2. So I'm going to substitute b equals to 1 into equation, let's do it into equation 2. So we're going to get 4 equals to minus a plus 2 times 1. So if we take the 2 across, we know we need to subtract it from 4. So I get 2 equals to negative a. So therefore, if I divide both sides by negative 1, I get a has a value of negative 2. I am now going to solve for a and b using the substitution method, and what I've done is I've just copied equation 1 and equation 2 again, and I'm going to use substitution method because this may be the only method that you know how to solve simultaneous equations with. Right, substitution method. I'm going to take equation 1 and I'm going to make b the subject of the formula. That is, I'm going to write it in terms of b. So that means I need to take 2a across. So I have minus 3 minus 2a equals to b. And now I'm going to substitute this expression into equation 2. So I am substituting this expression b equals to minus 3 minus 2a into the second equation. So in second equation, I have 4 equals to minus a plus 2, and I replace b with my expression minus 3 minus 2a. So if you have a look at this, I have only one variable in this, and it is a. So I continue simplifying, so I get 4 equals to minus a. I had minus 6 minus 4a. If I take the negative 6 across, I get 10. I add my like terms here. I have minus 5a. Dividing both sides of this equation by 5, I see, by negative 5 rather, so if I divide left-hand side by negative 5 and right-hand side by negative 5, I see that I get a equals to negative 2. So therefore, the solution will be a equals to negative 2, b equals to 1. So remember, although I've used the elimination and the substitution method, you only need to apply the method that you are comfortable with.